Hi, and welcome to the 61st installment of the ChessTDD series. Picking up where I left off from last time, as I said, it is a wrap on feature development. So now it is time to start writing some, they'll be laid out in the form of acceptance tests, but in a way this is, I don't want to call it smoke testing, because that sort of implies, I guess, performance, but it is kind of that. Like, let's run through a chess game and you know, see what happens. Up until now, I've been conceiving of scenarios in my head. So I went and looked up this, a couple of games. There's a Gary Kasparov game, and I think I found a Bobby Fischer game, and I wanted to start just kind of running through those. And immediately that poses sort of an interesting design problem for these acceptance tests. And I wrestled with this a little during the episode, which is the way I've designed it is to sort of say, here's a board, and let's pick one or more of the pieces and talk about their moves. It'd be nice to be able to easily visualize the board. So scenario one, or I should say scenario, and then, you know, when this chessboard, like what you're seeing now, and then maybe and there's another chessboard with the white piece moved up one. So I started to think about how to do that, like how could you do a diff between the boards and kind of infer the move from there, but I thought that that would get sort of difficult in a hurry when you started factoring in all the different types of moves and the fact that you might just have a piece gone from the board. So actually doing like a infer move on board seems like it'd be a good feature, but as I said, I'm trying to wrap this up, so I don't think I'm going to be doing that here. So what I settled for doing instead was starting to laboriously say, like, well, okay, let's do an initial snapshot of the game, you know, and just go through and make sure that every one of the pieces on this board is correct in terms of their initial moves. And then maybe we'll just kind of walk through the game and, you know, pick a handful of, like, interesting pieces. Maybe we just pick the moves for the piece that just moved or something. So some kind of randomized-ish representative set. Still haven't figured that out exactly, but what I did figure out is that this got fairly redundant in a hurry. And anytime, you know, and I do my best to take my own advice, and you'll see it here, it isn't just a matter of not like copying and pasting, but not doing redundant things. Long and short of it is, this is pretty laborious, as you'll notice quickly, and so I started to think here about, you know, is this really what I should be doing? And you'll see my solution to this here shortly. So basically, you're also going to see me wrestle with transposing X and Y. I seem to be unable to wrap my simple mind around not doing that. So an interesting thing to note here is that I started to get bored while developing this. I mean, that's not the interesting part. But the interesting part is if you find yourself bored while writing software, there's something wrong, because that means you're in some sort of autopilot mode. So I'm going through here and saying, like, okay, all these are the ones with no moves, and then I'll go in here and I'll do the 7 one, and that'll have some moves. And I was kind of even bored as I was, you know, doing this and also proceeding to get things wrong. But what I mean when I say boredom is a bad sign in software, I mean, it's not just bad because, you know, it sucks. It's bad because that means that you're in this kind of autopilot state where you're essentially doing busy work. And it can be hard to recognize because you don't really, you can slip into it and out of it, and you don't tend to naturally think of programming in any capacity as busy work. But that's essentially what's starting to happen here, where I'm not really giving this much thought. There's a lot of typing or copying and pasting. There's moving the cursor around. So anyway, what I'm getting at is if you're kind of zoning out like that, if you're in a mode like that, that's a pretty strong indicator that you should be stopping and thinking to yourself, how can I work smarter instead of harder? Like, I'm doing this drudgery. Why? Now, it may be that you wind up doing a quick, like, trade-off calculation in your head, and it's better to do the drudgery than to automate the thing that would relieve you of the drudgery, but you should at least be asking yourself if there maybe isn't a better way to do this. And there's a second consideration here, which is that these acceptance tests should be pretty readable. And, you know, the visual representation of the board is pretty readable, but now the rest of this is starting to get maybe not quite what I intended. I mean, you can kind of get the pattern here, and if you're looking through this, you can gaze at it for a while and say, oh, okay, well, rook has nothing, then there's the knight, then there's a bunch of nothing, then there's another knight. But we really want this to be quite visibly readable. So there's two things going on here that are striking me as they're tickling at the back of my mind as being problematic while I do this. And that, you know, sort of has time to eat at me because I'm not doing especially interesting development. I mean, granted, here I was struggling mightily with the transposition that I mentioned, but in general, I'm not doing anything interesting, so I have time to let these things nag at me, and eventually it does start to get the better of me here, and I think to myself, like, okay, how can we represent this a little bit better? And I realized I'd kind of gotten caught in this rut of using the same acceptance tests kind of over and over again without really branching out. It's all been graphical, and that's been nice for representing individual moves, but I have these... I have this powerful language descriptor programming language pairing, so I can start doing things that are, you know, more descriptive, where I can make this more readable. And I might think of ways to leverage that going forward in future episodes, because you're going to see me here stop boring you quite so much shortly. So I start to copy this, and I think it was at number 4 where I started thinking to myself, like, this is ridiculous. I'm not going to go do this for all the rest of the white pieces and then again for all the black pieces. So what can I do instead? And the first thing I can do is a random refactoring to make Code Rush happy. I mean, it's okay, right? All the tests are green. So what I started thinking of doing is, why not have something that just says all the white pawns have 2 moves or something? I was kind of thinking a little bit, should I say like all the white pawns can move 1 to 2 spaces in front of them? It's an option, but I decided to just, you know, assert that each of them has 2 moves. So I started to look at, you know, how might I accomplish that? And this is where I started to get into it. So I kind of pivot here, and for the rest of the episode, I want to nail down all of the starting pieces, but I only wind up getting around to actually all of the white pieces, which is okay. It's also starting to give me a sense of the scope of this testing effort, which is, I don't know that it's looking particularly realistic without some kind of rework of how I'm actually logging this stuff to go through and say, I'm going to go through an entire chess game and test it out. Like, if I were going to do that, I think what I'd need to do is write some kind of parsing scheme for actually parsing the moves for a chess game. And then, you know, maybe it's like some kind of console app, or I don't know what exactly. I could get into some weird code generation thing where I generated the SpecFlow files, but I think that may be something I get to in the productized version of this, where you would actually say, like, okay, maybe what we should do is implement some scheme that reads in an arbitrary chess game and, you know, verifies the behavior or something like that. But back here in a more grounded version of reality, I'm going to start out with a pretty simple scheme. And the first thing that occurs to me to do is, like, well, why don't I call into this other method where I'm, you know, passing in the X and Y coordinate, and then I start to realize, oh, because the table comes from the SpecFlow feature file. So I think about, like, well, can I create a table? This did give me pause for a moment, but I wound up going in a different direction. The long and short of it here, though, is that, you know, the good lesson is to keep these things readable, and I mean the feature file. So I guess it could be abstracted out to a general lesson, but in this case, you know, I want a human to come in here and be able to read these things, and I was drifting away from that without realizing. And I was drifting away from that without realizing because I was sort of in this autopilot mode. And it's sort of helpful for me to be recording these videos in a way because there's this sense in the back of my mind, like, am I keeping people entertained, or, you know, is somebody going to kind of grab me and be like, what are you doing? If you're just doing this by yourself, it's kind of easier to do the grunt work. But if you're going to be showing this to somebody, or if you've got a pair partner or whatever the case may be, it's kind of interesting. You tend to be less inclined to go into autopilot, or at least you feel the need to defend yourself. It's kind of an extreme case here because, you know, you're not going to want to watch me, you know, type the same line over and over again. So I don't know, maybe that's something you could take away in your day-to-day development. If it wouldn't be interesting for somebody to watch what you were doing and hear your thought process, maybe you should reconsider your actions. So I'm getting a little bit more into, I guess, the details here. So how do I express this? I guess I jumped right to link. I feel comfortable enough to do that. But I guess there isn't really any here, so I stand corrected. I am doing the simplest thing I can think of. So I'm going to iterate through these integers. I'm going to get the moves, and then I think at first I'm going to put the assert statement right in line. As a general rule of thumb, at least for me, I don't like to have assert statements. So I was contemplating it there. I don't like to have assert statements inside of any control flow, including for a while. It's not the end of the world, and I think especially in acceptance tests, it's not the end of the world. Here I'm doing it to kind of get green, and now I'm going to go back and refactor and reconsider. So anyway, not the end of the world, but I don't think great practice. It just strikes me as obfuscating. Like, if you have a test, it has setup, you act, and then you make some kind of assertion. If you're asserting in a loop, it gets sort of hard to tell what's going wrong if it happens at, you know, things 6 through 8 in the loop. So what I'm going to do instead, I'm going to do a couple of varieties of refactoring. Number one is I'm going to get to this, I've developed my own idioms here as time has gone on for spec flow. And one of the things I want to do is kind of get away from these get from context and set in context constructs that I have, and do something a little more familiar, which is going to be to use a property. In the unit tests, I use target. This isn't really the target as such, so I'm just calling it board. You're also going to see me forget how, like, the basic language rules work here, as I can't figure out why that getter won't compile. Yeah, it takes me a minute, but I get there. Something's wrong. Why aren't you compiling? Oh, yeah, got to return something. I guess I don't. I did a video series for something else with the new language features of C#6, and it strikes me I could probably implement that as a Lambda property. I forget the name of it. And you're going to see me here shortly sprinkle in a little bit of C#6 as a refactor. It's been kind of interesting to get all these new language features that aren't like revolutionary, but are all seemingly kind of oriented around compacting your code and making it more readable. I kind of love it for what it's worth. Okay, so anyway, now that refactoring is complete, so I'm getting rid of a line and all these different methods of excuse me, getting that board. So now on to the next refactoring, where I want to flatten this out and I want to get the assert out of that control flow statement by getting a little more functional. So this is a new C#6 language feature, kind of from the Java world, is using static. I forgot I needed to do that. I was thinking I could take the using system.link and it would, anyway, but it doesn't, so I had to fix it. That lets me get rid of that enumerable.range, which I don't find to be all that helpful in terms of readability. So now it's just range 1, 8. And I instinctively get it right that first time. What I want is select many, but I got a little bit caught up on what I was doing. So all I'm really doing here is flattening out this for each, which is something that with a good bit of practice, you start thinking a lot more functionally. So I want to get away from looping, and I want to get it back into kind of declarative land here. So for all the integers, you know, so I've got this range of integers, take 1 through 8 and do a transform on it where I'm going to go and get the moves from, I'm going to translate 1 through 8 into this collection of moves, and then assert that the moves are equal to 16 in terms of their count. Then I'm going to remember that I want select many, so giving me these collections of coordinates from each integer, not just, I don't know what that would return exactly, I guess. Yeah, I don't know. Weird. So now I have this flattened out thing where just all in one declarative line, I'm figuring out how many moves total this gets me. And I'm going to do a rename. Usually I like to keep it tight there, but I kind of like calling this x coordinate. Thought about just calling it x, but that seems a little unclear, I suppose. Okay, so having done that, I kind of want to get rid of it, but you know, I've got a taste for this now, so I'm going to make a declaration for the white pieces about all non-knight pieces. And this is going to look pretty similar to what I just did, so hey, great. I don't know what I was doing. I couldn't remember. Oh, yeah, I couldn't remember that was. So I'm going to copy that to the clipboard and do the same thing and really compact this this scenario down to something a lot more manageable. So similar kind of deal, and I've got a template here. Really, what I want to do is say I'm going to vary only the initial selection here. So I'm going to call this non-knight coordinates, and it's going to be range again. I don't know why I put the enumerable in there, force of habit, I guess. And in this case, I'm going to say that I want to get the range, but where the value is not either 2 or 6, because that's where the knights sit. Might be good to give those magic numbers 2 or 7, to give those magic numbers names, but I didn't wind up doing that here. Still got some magic numbers. I don't know that it's the end of the world in this case, just because the description in the attribute kind of tells you what's happening, but still it could be clearer. Oh yeah, I forgot about my lambda. There we go. All right, so now what I've got is this collection of all the non-knight starting columns on the board, and I'm just going to go and do the same thing, and this time I'm going to assert that when I get done the count is 0. So for each of these non-knight coordinates, I want to go and I want to do this get moves from again with the x coordinate, and this time it'll be 1 for the row. And I'm going to get a count of that. And I'm going to verify that the count there is 0. None of these pieces should have any moves. So far, so good. But I get a little bit greedy here, I guess. I think before I did any assertion, well, I've got everything green. I'm looking and saying like that, that's going too far off the screen, so I'm going to extract this logic here. And started to think about being able to just specify the row, but I wound up, instead of having board.getMovesFrom and then board coordinate .for, I'm just going to create this thing called board moves to make these calls shorter. And see, at first I was thinking, oh, I'll just specify the row, but realized that wouldn't actually get me what I was subbing in for here. So I copy this out, return it, and then realize, oh, I have 2 different variables that I need to pass in here. And I'm going to probably transpose row and column once again. Yep. Sooner or later I get it more or less right. So int row, there we go. I'm just going to call them X and Y. Make life a little easier. And rename that now that it's not about the row. Okay, that's fixed. And then I can shorten this considerably to just board moves. And that's going to make this not run off the line. Now I'm going to get confused about why I'm not compiling. And I'm going to start doing a bunch of undo before I realize it doesn't matter. It is a little bit humbling to go and make all of these mistakes, you know, even just to come back and watch myself and think, like, I mean, like, how many times are you programming and you think to yourself, man, I'm an idiot. How did I not realize that? So it's been a humbling experience doing all these episodes where I capture all those moments on video. Anyway, going to be easier here probably just to type out the method and say that I want to do this for X coordinate, and then what's this one going to be, 2? And then to make sure that I'm, once I'm compiling, I'm green after this refactoring. Then that looks good, so finally it's time to go and actually make an assertion in this method I was building. Not entirely clear on what I'm doing in this. There we go, assert. And finally I'm going to say there shouldn't be any moves for this moves count, which I believe goes green. Now I get to go in and delete a bunch of other stuff too. So this, oh right, I want to specify here that it's white, because I'm going to do the same thing later for black with the pawns and the non-knight pieces and make this relatively compact. So time to delete the non-knight pieces, and then I'm going to wrap it for this episode with a little bit of housekeeping. So we're kind of getting down into the end here. I'm not sure exactly how many more episodes there'll be, but I'll at least get this squared away and then maybe do a handful of specific scenarios from these games, and then anything that they expose that might be wrong that I haven't caught so far I'll fix, but that's really going to be just about it. So I'm going to go commit this code, and yep, this is still in process, so I'm going to leave that and do a commit. And that's going to be it for episode 61. As always, thanks for watching, and I will see you next time.